The KJ-500 is China's most advanced airborne early warning and control aircraft, having three important features, which are good detection capability, good identification ability, and quick responsiveness. The aircraft carries a fixed dorsal radome containing 3 AESA radar arrays for 360-degree coverage.
Special aircraft is an important part of military technology equipment system. It is also the key weapon equipment that determines the victory or defeat in modern air combat. Among them, the early warning aircraft independently developed by China has formed a cluster force and provided important support. Shaanxi Aircraft Corporation or SAC, as the main manufacturer of more than 30 types of special aircraft such as KJ-200 and KJ-500 anti-submarine patrol aircraft, is known as the cradle of special aircraft. Today we will explore how the domestic special aircraft flew from here to the world.
After 50 years, this desolate land has grown into the cradle of new China's special aircraft. A seed planted in 1969 for the development of a transport aircraft has now grown into a towering tree. At that time, SAC developed more than 30 types of special aircraft in succession with almost nothing to start. These include star models such as the familiar KJ-200, KJ-500, and anti-submarine patrol aircraft, which filled many gaps in China's aviation weaponry. This not only marks the new China's overall improvement in air early warning, command and control, early warning detection, identification and tracking capabilities. It also shows a powerful aerial information command platform. Among them, the KJ-500 is a well-deserved star model in the early warning aircraft family. As a new generation of all-weather, multi-sensor airborne early warning and command and control aircraft with completely independent intellectual property rights in China, it mainly performs air patrol, command and control tasks. Can perform tasks across the territory under complex weather conditions. It represents the highest level of current Chinese early warning aircraft.
KJ-500 is also called Gaoxin number 10. It is our first truly self-developed and designed. It is different from KJ-2000. It uses our own Y-9 platform. Let's look at this picture. You see so many small glitches, both above and below. These are top secrets. These are all electronic warfare antennas. There are many on the plane, including these small thorns under the belly of the plane as you can in the picture are also electronic warfare antennas. As an early warning aircraft, why install a bunch of small antennas? Well, because it can airborne early warning, command and guide, and can conduct electronic reconnaissance and collect intelligence. And it can also engage electronic warfare. So it is equivalent to multi-function superplane, which must be.
On the real battlefield, you have something to detect, and something you can't detect. There are interference and confrontation. We not only need to be able to detect and suppress the opponent, but also to achieve one-way transparency on the battlefield. I can see you and make you not be able to see me.
In terms of early warning command, target search, identification and follow-up, an early warning aircraft assume an important role of the air command platform. So it is also called the eye of the sky. They all flew to the sky for the first time on this runway of SAC Faichenggu Airport. This is the unpainted KJ-500 is undergoing some related preparations for the factory flight test before delivery to the Army. Test flight is a very important process in the development, finalization, batch production and delivery of the aircraft. The procedure is very complicated. The flight test not only needs to verify the various systems and performance of the aircraft, so that all technical indicators meet the requirements, but also test the limit performance and boundary of the aircraft. Can you tell us about special aircraft like KJ-500? Is there any difference between its test flight and ordinary airplanes?
The flight testing of a special aircraft has two parts. One part is the flight of the carrier aircraft itself. The other part is the flight testing of the mission system. The test flight is to check the safety of the aircraft. The other part is to check whether the capability of the aircraft has been maintained at a high level. Only after passing all the flight tests can it be delivered to our Air Force.
The development of early warning aircraft is a huge and complex system engineering. Any small mistake may lead to the failure of the entire project. In the development of the KJ-500, SAC has successively overcome a series of problems after the installation of the Big Mushroom early warning radar, such as the aerodynamic shape changes, the stability decreases, and the stall characteristics deteriorate, which marks the performance level of China's early warning aircraft top of the world. There used to be the largest assembly plant in Asia. The most advanced early warning aircraft KJ-500 in China is assembled in this factory. Here, inside of the factory, I just feel very small. We saw that this factory plant contained multiple aircraft. The early warning aircraft has many electronic devices, wide frequency spectrum and high power, and the electromagnetic environment on the aircraft is extremely complicated. This is particularly easy to cause various interferences between devices and hence unable to make equipments work normally. In order to solve this problem, it is necessary to achieve electromagnetic compatibility of the entire aircraft. Simply put, electromagnetic compatibility means not only to ensure that our equipment can operate normally, but also to interfere with the enemy's detection signals, and at the same time to make the transmission of our information normal and successful. Sounds complicated. In fact, this has always been a worldwide problem. Some of the electromagnetic compatibility issues are resolved through laboratory analysis and testing. This is the Electromagnetic Compatibility Laboratory. In the research and development process of the early warning aircraft, here is used to test the electromagnetic compatibility capability. Through experiments, effective electromagnetic waves can be reliably emitted, and ineffective electromagnetic waves can be filtered out. No electromagnetic interference between each other. It feels soft and bumps like a sponge. It is actually made of absorbing materials. Absorbing materials have a high absorption rate of electromagnetic waves. With it, a relatively pure electromagnetic environment can be created. In this way, the test results of the electromagnetic compatibility experiment can be more accurate and realistic. The development of aircraft is inseparable from an iron bird. This iron bird is used to verify the aircraft flight control system function and test bench. This is huge iron bird. Here is the Iron Bird laboratory simulates a complete aircraft flight control system. It is used to test the function and performance of flight control. Its mechanical transmission and electronic flight control system is exactly same as that of a real aircraft. It is designed for KJ-200 medium-sized early warning aircraft with completely independent intellectual property rights. Later included KJ-500 type. This testbed has laid a very solid technical foundation and platform. Affected by the curvature of the Earth, ground-based radars have deadly blind spots when detecting aerial targets, especially low-altitude targets. So people thought of creating a radar that looks down from the sky. The early warning aircraft was then born, with the development of research and scientific progress. In addition to the radar detection function, the eye is also equipped with equipment such as identification of friend or foe, electronic reconnaissance, and electromagnetic countermeasures. It quickly transformed from a single eye into a big brain, capable of analyzing intelligence, judging from information received, and issuing instructions. As usual, it takes at least 5 years to develop a new type of aircraft. But it only took 20 months for SAC to send the KJ-200 to the blue sky, which was a miracle in the history of the aviation industry.
China is one of only 5 nations in the world can independently produce early warning aircraft and owns independent intellectual property rights.
China's legacy is the Y-8 plane. The first Y-8 aircraft after the conversion in 1975 was born here. With its excellent performance and space, the Y-8 aircraft makes it an ideal modification and development platform for follow-up. Electronic reconnaissance, electronic countermeasures, early warning command, anti-submarine patrol and other special mission aircraft. Today we meet Mr. Ding, the chief designer of Y-8. How are you, Mr. Ding? Why can Y-8 be a modification platform for so many special aircraft?
The Y-8 aircraft has a large volume. and its flight distance and flight time are relatively long. In addition, it has a large load capacity. All special aircraft equipment can be installed, so it meets necessary requirements for such special aircraft.
We must understand the final assembly batch production line. This is a very young production line. It combines the concepts of digitization, information integration and artificial intelligence technologies. It is mainly responsible for the final assembly tasks of mass-produced aircraft such as the Y-9 anti-submarine patrol aircraft. This plant is bigger than the total area of 2 football fields. It is different from the assembly plant we visited just now. The number staff of the pulse production line is very small. The production efficiency has increased by 30% compared to before. This means that the final assembly pulsation production line can provide mass production of aircraft. Let us now ask Mr. Zhang, the chief engineer of SAC, about this amazing production line.
This assembly pulsating production line is divided into 5 stations. After the process of optimization, redesign, and re-optimization, all the tasks are evenly distributed to each station, which achieved an optimal process of the whole production of the parts of aircraft entering from this end and the whole machine coming out from that end. The term of pulsating production line is just an analogy. It means that stays at each station for a certain amount of time like a pulse in the process of flowing water. Then after the stay, everyone moves forward in collaboration as such tasks on each station are done in a most effective way, which achieve the production cycle of each aircraft on time in accordance with the precise production plan issued by us. That is the often so-called mass production, if you may.
Today, domestic-made early warning aircraft have frequently appeared on the wargame field. Undertake the important task of commanding air operations. Cooperate with various types of fighters, ground radars, surface-to-air missiles and other forces to jointly exercise joint reconnaissance, airstrike and joint air defense operations. Under the leadership of the KJ-500, multiple fighter jets formed a joint attack. The early warning aircraft can be in charge of the whole process, and the fighters made a network, searched, guided, and attacked. It is with a small platform, deep and detailed warning, high performance, and truly belongs to a new generation. Although it is small in size, it has very powerful functions. It can be networked in the air at any time to integrate air and ground information. It can also guide multi-domain and multi-level fighters to perform differentiated and precise strikes on multiple lock targets.
There are not many countries in the world that can develop early warning aircraft, and even fewer countries can develop advanced new generation early warning aircraft. The development of KJ-200 solves the problem of whether China could have independently developed early warning aircraft. The successful development of KJ-500 actually shows that China's early warning aircraft equipment level has reached the advanced level in the world. It also answers the question of whether China can equip its modern forces on a large scale. This is of great significance to the development and construction of the Chinese military. It is possible that at a later stage, this early warning aircraft will serve as a backbone force in our modern combat system. It will be of great significance to the improvement of our Army's overall combat capability.
With advanced early warning aircraft, there are eyes and brains in the air, and with a complete spectrum of special aircraft, advanced fighter jets such as J-20 and J-16 now can exert their maximum combat effectiveness in modern warfare.
Both fighter jets and warships are inseparable from various high-precision radars. And who made the eye of radar? Today we will take you to a military worker who challenged the machine to create a radar eye with extreme precision. His name is Hu Sheng.
Whether it is an airborne radar that can explore targets in 360 degrees on a large early warning airframe, or a phased array radar installed on a large ship, these key core components of radars are carefully carved by Hu Sheng. Whenever he was given precision machining tasks, Hu Sheng didn't know where these products would be used, but he knew that the contest between him and the machine had begun again. Precision is the key to processing high-end radar components. The core component error of the early warning aircraft radar cannot even exceed 0.004 millimeters, which is about 1/20th the thickness of a hair.
It is very thin to see with the naked eye, and people with poor eyesight can't see in that limit.
Hu Sheng's engraving tool is this computer numerical control machine tools or called CNC machine. But the accuracy of the machine tool is only 0.01 millimeters. This means that the accuracy of the parts that Hu Sheng wants to engrave has exceeded the equipment limit.
No one has done it before. There are a variety of special materials that have never been seen before, including composite materials that cannot be found in books, literature, references and journals, which are particularly difficult to process.
He must challenge the machine.
Because any research and developed product or military product we make would have time constraints. It can't be said that part is very difficult and it must take me half a year. In fact, I might be given only 3 days to finish it.
Choosing the most suitable cutting tool is a key step in precision machining. In the 14th Institute of the Chinese Academy of Electronic Sciences, Hu Sheng is the most proficient in cutting tools in the entire factory. He can quickly and accurately select the most suitable one among more than 1,000 cutting tools.
It is often said that 3-point kung fu and 7-point knives. To choose several cutting tools among 1,000 kinds, in addition to knowing how to use suitable tools, one must also be familiar with the performance of this machine, and one must also be able to program and design various tooling himself. At each level, when I turn on the switch, I look forward to the good results coming out.
But it is far from enough. The machining error of precision parts is within 1/10 of millimeters. For example, a 1-meter-long aluminum alloy component with a temperature difference of 1 degree Celsius will produce a deformation of 0.0243 millimeters, which far exceeds the accuracy requirements of the equipment and parts. How to solve these problems? Hu Sheng thought out many ways. Before processing, he will preheat the machine. After the temperature of the machining tool is relatively constant, then start the processing. He also divides an 8-hour shift into 16 or 24 intervals, and controls the temperature difference between each interval to not exceed 0.5 degrees Celsius. He measures once every time interval, and adjusts the error caused by temperature difference in time. All external factors that affect temperature changes should also be eliminated one by one.
How to use some ordinary equipment or use the best domestic equipment to make world-class components is something a military worker must consider. I have to ensure that with equipment I can reach an extreme to preserve its accuracy or beyond its accuracy range to ensure the stability of our military products to meet its special requirements.
With years of hard work and accumulation, Hu Sheng has also developed the unique skill of judging whether the tool is worn or not by constantly observing the machine tool. When the tooling machine is running at high speed, Hu Sheng can see the size of the processing fringe, and can hear the change of the processing sound, and touch the machine with his hand to feel whether the vibration of the tooling machine has changed.
Achieving accuracy depends on people, but the tool also is an important part. No matter how high precision we want, it is done by milling cutters or by turning tools. The tool is used for processing. Whether it can be used well is a basic skill.
Relying on perseverance and rigorous meticulousness, when processing the core components of the early warning aircraft radar, he made only a component to achieve an astonishing accuracy of 0.003 millimeters, which actually exceeds the design specifications. With the smooth delivery of the products, the ingenuity of the military workers has laid a solid foundation for the stability and reliability of my country's first large-scale phased array early warning aircraft radar.
A few years later, these parts one made were declassified, and I learned that what we made were used on the early warning aircraft radar. That project is very important for the country. We are very proud of.
After graduating from a vocational high school, he became a role model of national technician expert and won a National May 1st Labor Medal. Hu Sheng is now a leader in the field of precision machining and manufacturing in our country. He has often undertaken projects of airborne fire control systems, airborne early warning systems, shipborne fire control systems, and also participated in a series of internationally advanced key scientific research projects.
I want to keep on going and just not take a big step. I can walk a long time, but I can't stop.
With advanced early warning aircraft, there are eyes and brains in the air, and with a complete spectrum of special aircraft, advanced fighter jets such as J-20 and J-16 now can exert their maximum combat effectiveness in modern warfare. Among them, the anti-submarine patrol aircraft is called the submarine nemesis. So how about China's anti-submarine strength? Let's listen to the interpretation of military expert Cao Weidong.
First, there is a large radar under the nose. This radar through photoelectric equipment can detect submarines using periscopes or buoy communication sonars. Second, we can see its tail, which has a long and big tail. This is a magnetic anomaly detector. When a submarine navigates underwater, it will destroy the original distribution of the magnetic field. We can discover underwater submarines through finding changes in the magnetic field. Third, when a nuclear submarine sails underwater, a large amount of heat energy will be discharged due to the cooling of the nuclear reactor. We can find the track of the submarine through detecting the infrared changes. Fourth, we threw down the buoy sonar. These sonars can detect the noise of underwater submarines. Through analysis, we can determine what kind of submarine is underwater and how it is moving. Through this comprehensive approach, we can catch the submarine that is hidden deep under the sea.
The plane also carries various anti-submarine missiles. Once a submarine is detected, it will be destroyed by means of using various missiles accordingly. We visited recent anti-submarine live ammunition along with KJ-500. This short video clip shows how they destroy the target as if the spot of a submarine being detected.